Once they what's the end?
Okay. Who gives me permission to look at your diagram that you submitted for homework? Anybody? Huh? Yes. Okay. Let me just. Pardon. I expect it to be messy. That's okay. Let me just call up. Get it out of latte. Sorry to pull the plug on that. Because then we can use that to talk about it. Diagram of Twitter architecture. Only 17 submissions.
What?
I said only 17 people submitted. The rest of you, the other 13 or 12 of you who have not submitted, please do so. This is very important to understand the material of this course. I'm not kidding. I'm not kidding. Okay. Plug it back in. All right. What's your name again?
Chunya.
Okay. Oh, nice diagram. Omnigraphal.
Well, that one was copied from the slide, but
Oh.
the one below.
It's still omnigraphal.
Yeah.
Okay, awesome. Now this is yours?
Yeah.
Sweet. What? Okay, so excellent. So let me go to the. Now we have something to look at. So who wants to take a stab? And I know it's complicated. I probably couldn't explain it clearly either, but I could try. But this is like the essence in a way. If by the end of the course you should be able to understand and explain this question, because it's the essence of how you approach a complicated scaling problem using service-oriented architecture everywhere, using caching in very intelligent, clever ways, and building a system that's this complicated. Was anybody surprised that it's this complicated to run Twitter, by the way? Huh? Yeah, were you? Yeah, I mean, this is probably still oversimplified. The other thing that's interesting about this is that it's not just like, oh, give it premium gasoline, run it faster and it'll just go faster. It's like really deep thinking about the behavior and the characteristics of the whole flow of information, and even the difference between a tweet showing up as a result of a find versus a tweet showing up because I'm looking at the timeline. You would think they're kind of similar, but they turn out to be totally different in the way they support it. So I was surprised too. I wouldn't have known, which is why I love this presentation so much. Okay, so who wants to try to take a stab at why there's a difference, what the difference might be, anything at all that you can comment about that point? And really, it's safe. I tell you, I don't know the answer either. I just want to talk about it. Yes?
Okay, so for the way that search results are handled, he talked about how they made writing really inexpensive, and that because they merged the results at the end, that reading was more expensive. And while on the other hand, when they feed you your timeline, the writing is really expensive, so that they can do a really quick read to get your timeline.
That is, you hit it on the friggin' nose. Okay? Exactly. I'm done. And it's a very interesting insight. Like if I want to update 1 million people's timelines, that better be very fast. I'm willing to make it appear 100 milliseconds later, do some more stuff at the beginning. But on the other hand, if I want it to be the result of somebody doing the search. I don't mind if the search is a little slower. I just don't want to penalize the people that are just posting because somebody might search for it. And that's why this thing is this way. Wow, this is, did everybody get that? I won't go through the details here, but let's look at it a little bit. So the other thing that's very important here, and the homework you're going to get on Monday is going to be about using APIs, is the idea of services having APIs. I was digging through various lists of services that I can find, and I found, for example, well, we all know Twitter has an API, but like Wikipedia has an API, and what else? Weather.com has an API, and Yahoo Finance has an API. And so if you're building a system that requires this stuff, you can reach out to another service to provide it, like the famous Major League Baseball API we talked about on Monday. But the same exact principle applies when you're building a service-oriented architecture, where it's all, as far as the world is concerned, it's one server. But all these things connect to each other by APIs. And all these things, not every one of them, but a lot of them, if not most of them, talk to each other, even internally, and that's the concept maybe that's not immediately obvious, talk to each other even internally with HTTP. Okay, when there's two servers, server A and server B, they're next to each other in a rack, in a computer set, not in a rack, in a rack.
Oh, I did not.
Thank you for laughing at my stupid jokes. I appreciate it, honestly. But when they're together, they're next door to each other, there's a wire between them, there's still a protocol that comes into play. And that protocol, by and large, is going to be HTTP. Great. This is a very good, I haven't read it, but it looks good, so excellent. Any other reactions, thoughts, questions, confusions about what you saw in those two videos? Yes?
So, one of the things that I sort of, since I'm pretty much never used Twitter, I don't really know about, is that there's many different ways to post tweets, right? You can go to the website, you can use your phone, like you can just text and do all this stuff. And so I was wondering how you think they handle that. Is it a different service that takes the mobile SMS and turns that into something else, or is it one service that just says this is the endpoint?
That's the first thing.
Okay.
It's the first thing, and it's very interesting because I actually had an app. I still have it, but it's dead. Which called BlogBridge, which did use the Twitter API like 3 or 4 years ago. And you think about it, if I have an app that I'm selling and I'm making money, like TweetDeck or one of those things, and I'm making money at it because I'm selling a really great app. I paid $5 to use it. And I can submit tweets or I can read tweets, that's great. I'm making money essentially on the back of Twitter, the company. More than that, if Twitter decides to start making money as they are by posting ads in your timeline, my app can elect not to show the ads. So there's a real technology strategy consideration to an API. It's not simply something there that programmers put in for everybody to use. And so, for example, in your case, it would be a balance between the expected volume of tweets coming over, let's say SMS, the cost of running an SMS server, the kind of performance obligation you feel like you should provide to those people, that would lead you to figure out how to configure that server. So it would have very different policy and strategy parameters. A very common thing in APIs, and we'll see this with the homework on Monday, is that one of the ways to overcome the issue of cost is that, and you might have already seen this in your own experiences, is to ask the programmer to get they call it an authorization key or something like that. So you go onto the XYZ company's website, to the Yahoo Finance website, you request an authorization key, you give them your email, even if it's free, you get it, it's like a 64-letter string or whatever. And then in your application, in your little app, you got to stick that key in. And that key proves authorization that you're allowed to do this. And that's one way in which they start controlling and monitoring the use of these services. Because now Twitter can, or Yahoo can, as they do, say that you can get a key for free. But this key will let you only do 100 tweets or 100 stock prices per day. So I'm not so worried that you're going to make a lot of money, building the next Bloomberg machine, and basically Yahoo's doing all the hard work. If you want to actually allow 1 million price requests per minute on the Yahoo Finance, that's cool. We'll let you, but you're not going to be able to use that free key for it. You're going to have to pay money for it. So that's a very, very typical model where you're asked to get an authorization key of some kind. That key gets embedded in your code, right? So when the API, when the line in Typhoeus or whatever makes a request to that server, it sends along the key, and that proves that you're authorized user of that key and user of that service. It turns out that that Twitter fairly recently did a major overhaul of their APIs that essentially disallowed a lot of people from even writing applications against those APIs. And this was mentioned a little bit in the video. If you are a big company like maybe a news service, like New York Times, who wants to get hot breaking news off the Twitter fire hose, they call the Twitter fire hose is the sort of the union of every tweet everybody does at any moment. Which means a massive volume, which means they probably have an army of, which one of the servers is it? The Hosebird or one of these guys, to like a dedicated Hosebird to generate enough capacity so the New York Times can get their full fire hose. Well, the New York Times is paying a lot of money for that. So even a year or two ago, anybody could see the fire hose. Now, no longer the case. So by having this authorization level, sort of requiring this magic key, you can decide on policies, you can charge money, and so on. None of that stuff, of course, pertains to this, right? This stuff is all internal to Twitter, and there's none of that going on. However, interestingly, to tie it to the news, obviously, in the case of Twitter, in the case of Google, in the case of any number of these, Facebook, or whatever, these servers are not all necessarily in one building. In fact, it's very likely that Twitter has data centers, let's say in London or in Beijing or wherever, closer to the people that are using the service, and that's where a lot of this work happens. So security becomes a really big question. Like, how does the data, okay, you need this SSL here, but what about in here? Do you need SSL in here? You need these lines to be secure, because really, they're internal to the Twitter service. So why would you need it? Well, it turns out that with what the NSA is doing, that they've actually been able to intercept these internal wires, so that even though Google is thinking that they're communicating between server A of theirs and server B of theirs, even though they're in different locations, the NSA, and I'm sure all the other security agencies, have been finding a way to hack into that. So now Google and Facebook and all those guys are even encrypting these internal connections. So the whole thing about authorization keys was about the outside world dealing with the service, and that's security and authorization and business model. But the second level of interest is when you talk about privacy and security agencies. Now suddenly those issues come inside the service as well. It's very, very interesting. Very, very interesting. And it's very complicated. I mean, when you think about it, when you type a Google search and you just imagine what is going on out there, what the servers are that are flying all over the place in different countries, data centers with thousands of servers. And when you have thousands of servers, of course, one of them breaks every minute, literally. So they have to have that. How do you replace them? And what happens? Why does the service not break down when one server out of 1,000 stops working? What's the architecture that permits this? Here they have 100 Hosebirds. In fact, I asked Rafi, I asked him, what is a realistic number of concurrent? Because I did a back of the envelope calculation. One of the things we need to do to understand scaling, or to understand what capacity we need to scale, is to try to make some kind of a estimate of what the load is. How many tweets per second, how many concurrent logged in users are there per second, because that'll allow you to compute, how many of these Hosebird servers you need. Because you understand, right? Each of these little slices is a different computer. Different computers. There's like, in this picture alone, there's like 30 computers. Anyway, very interesting. Any other thoughts or questions that were confusing about these presentations? Good. All right, great, thank you. Where is my? Oh, close the window. That's silly. All right. No, that's not the one. How many of you had not had a Twitter account before this homework? Ah, interesting. A lot of you. So what's the story with Twitter? It's no longer cool among the kids? Come on, tell me. I want to learn. I'm not looking. I'm just. How many? Yes.
I'm not American.
Yeah.
Might be.
Twitter's not big in Europe.
I don't think it is in America.
No, I believe it. Yeah.
Twitter is just cool for getting news.
Pardon?
Twitter is used to get news
Yeah.
and information.
Yeah. Okay. Anyway, I mean, it is. Yes.
You're just saying that it feels like Twitter is for people you don't actually know.
Yeah. Right.
It's not as social.
Oh no, it isn't. It's true. It's true. It's funny too because originally it was for social things. In the original beginning, it was like, oh, what if we had a blogging platform where all we put out was the titles? Well, what would that be? And that was sort of the original vision, from what I understand.
A lot of young people do use it socially.
Uh-huh.
A lot of young
Yeah.
people do use it.
Did you have an account?
Yeah.
Yeah. Yeah, I have an account and I use it for personal PR basically, to be honest. So I have like when I have something, I read something interesting, I'll post a link and I try to get followers just because it's, I want to keep my name out there. But then I have a list of about 100 people that I think post really interesting things, and I do look at that pretty religiously. But then it becomes almost like a newsfeed for me. Like I don't communicate one-on-one almost ever over Twitter. But that's neither here nor there. It was just a useful exercise for our purposes. Okay. So let's talk about each of these things. I'm just going to ask a different person to answer as I go around and ask. What can you say about your name on Twitter? Who can say, what is your name on Twitter? What are the things we know about it? I'm going to start with you. It's the easiest one of all. So you win.
It's going to be a unique alphanumeric username, which you use to log in with and appears on your profile in a media space.
Perfect, great. Okay, what does it mean to mention?
I have a question.
Yes.
So you have.
Where are you from, by the way?
Israel.
Israel, okay.
So you would have. As I try to analyze the video that I see, and you have sort of a Redis instance for each user, each username.
Mm-hmm.
So that's also.
That's their timeline.
So so every username has unique Redis instance.
I think that, but they probably have a bunch of other ones. But yes, I think that they have for not every username's timeline. But there was another thing about whether they're logged in currently. I think that if you're not logged in, it at a certain point disappears again.
Yeah.
It goes to permanent storage.
Right.
Yeah. But Reddit, we will talk about Reddit, but it's huge. I mean, just the way they use it. Any other thoughts? Okay. Who wants to talk about the concept of mentioning on Twitter? How about from the back 2 rows? Somebody. What does mention on Twitter do? Go ahead.
Yeah, I just said it was entering an account's Twitter handle in a tweet allows the user of the mentioned account to see the tweet and is searchable by the mentioned user's Twitter handle.
I'm putting an accent in front of me.
Yeah.
Allows that user. Okay. Yeah. Okay. There's. Okay. That's fine. What does it mean to follow? Oh, typo. What does it mean to follow? Somebody from the back 2 rows over here. What does it mean to follow?
Subscribe to another person's account and your tweets will appear on your phone tab.
Yeah. Exactly. Okay. We know what a tweet is. Okay. What is the Twitter stream? What is the Twitter stream for a person? It's up there, but give me a little bit more detail. Twitter stream for the person?
All the tweets that belong to an individual person.
Okay. Does a tweet ever belong to more than one person at once?
If they're mentioning.
Okay, that's a
retweet.
Oh, retweet. Yeah. Okay. Good. Yes.
There's a question?
Yes.
If you retweet something that was mentioned before, it's the intersection of all yours and mine friends.
Right.
But if someone else retweets it, then everybody can see it.
All their.
I think all their.
All their followers.
Yeah.
So if you retweet something that I tweeted, all of your followers.
I think it's just basically like tweeting. It's the same thing.
What does it mean when you do a mention, but you put a dot in front of the @ sign? Why do people do that? You've seen it, right? Dot at pedo.
Personally, email, send them a message.
Does that make you nullify it?
Everybody does it, but nobody knows what it does. So it turns out my son is a social media guy at a company in New York. I asked, what's that dot do? Yeah.
I actually looked that up.
Uh-huh.
I don't remember what the exact wording was, but there's a difference between a mention at the beginning versus a mention in the middle.
Yes.
And even if you say like at Pedo Salas and like at Alex,
Yeah.
without the dot, only the first mention would still be that like special first mention.
Yes, yes. And then?
And like the at Alex would be like the weird internal
Yep.
one, even though it's.
And what's the
there's
effect of
still
being
no
the first
overtext.
mention?
The effect is that it's. I don't remember what the effect is.
Okay.
I never used Twitter.
Okay, that's fine, that's fine. But you're on, that's cool, that's cool. You're on to the basics. Anybody want to add to that? What does the dot do? Why would you do a dot? Yes.
I think without the dot, I was mentioning like this. It was like it's like sending a tweet to a person versus just like saying something about the person with the dot.
Kind of. I mean, the way I understand it, and again, you guys can
Dot is, like,
Google.
about the person, and the without the dot is with the dot it's about the person, and without the dot it's to the person.
Kind of. I mean, the way I understand it is that without the dot, if I say at pedo, great class today. Never got those. But at pedo, great class today. Then all my followers and all your followers would see it, but nobody else. Oh, no, sorry. The intersection of my followers and your followers. So only people that follow you, who also follow me, would see it. But if I say dot at pedo, great class today, then everybody who follows you will see it, whether or not they know who I am. So I think you were kind of in the right area.
That's good to know.
Yeah. Yeah, it's very interesting, right? And this is all important because when you guys go to implement your nano Twitters, oh, I forgot something.
Well, the thing I think is really weird about that is that it's a weird, like very technical privacy thing.
Yes.
That's not a setting.
Yes, I agree.
And it also uses up a character.
Yes, I agree with that. I agree with that. I think it's and like the DM, putting DM in front. I mean, I have no idea what that does exactly. So it's like it's very, and even the @ sign and the hashtag. It's all very geeky. And I think where it came from, first of all, it was built by geeks, but also it was originally meant to be used over text messaging, and those were the limitations. I just want to be able to send a text message out.
Sure.
But it is weird. And really, I think 99% of the people that put a dot don't even know what it does. Yeah.
Yeah, I think Rafi explained it that it's not a setting because they want the default to be the intersection.
Yeah.
Because of, when two celebrities talk to each other,
Yeah.
it puts a huge amount of.
Right.
Yeah. So they want to sort of to be the default to be just the intersection, so it won't be spread to millions and millions of people and then retweeted again.
Right. That was interesting how they had special handling for the celebrities, a special server for the celebrities. That was very interesting. Do you know, I don't know how much you guys keep up with tech news, but Twitter, first of all, is under pressure because financially they're not doing as well as they ought to be doing, and their user growth is not as fast as they want it to, as the stock market wants it to be. And one of the things they're doing, and they contemplate every so often, the question of doing what Facebook does, which is to sort of use some kind of machine learning algorithm to curate what tweets you actually see on your home page, instead of simply giving you the last N of your followed people, to actually show you stuff that you might find interesting. Because obviously, if you only get whatever the number is, 200 on your screen, and you haven't been on for a week, it's kind of random what you see. You may not see good stuff. But the fight there is that Twitter's, reputation or style has always been, we don't do any machine learning. But the second problem that Twitter has a lot is that when you first sign up to Twitter, like, so my wife said, what's Twitter anyway? Should I sign up? And of course, if you sign up to Twitter, there's nothing there. And you don't know who to follow. You don't know what the point is. Yes?
Well, now they do recommend you, and they automatically sign up.
Mm-hmm. Right.
I did this beginning of the semester, and I got signed up for 200 tech clubs.
Interesting. So that whether that's new or whether the thing I'm describing is still coming, I'm not sure. But I know they're working a lot on the. No, I don't think so, because this is the what they call the non-logged in user experience. Like if you go to twitter.com and you're not even logged in, what do you see? And it's very interesting. I mean, I don't know if you guys like this kind of like strange detail, but it's very interesting because Twitter, when the financial analysts analyze a company, they ask like, how many users do you have? How many users do you have? And of course, the number of users of Twitter corresponds to the number of accounts they have, and perhaps then of those, how many people log in any given month. But Twitter says, my God, but in addition to the users we have like 10x that many people who use it without having an account. Why don't you count that? Well, because there's no way to count it. So the whole non-logged in, what they call the non-logged in user experience, what do you see if you're not even logged in, is something they're trying to make better. And they're constantly in this battle, intellectual battle, between doing what will satisfy the financial markets and what maybe they get social pressure to do with what they feel is their essence. Because they don't want to be like Facebook, because they become like Facebook, they're going to lose against Facebook. So it's a very interesting dynamic. But for our purposes anyway, the question is, you know, when you're not logged in, I think, well, let me just try.
Yeah, so how do you use Twitter without being logged in?
I think you get the fire hose if you're not logged in.
No, I just get a few. Yeah, I just get a few sort of pre-planned tweets that say things like, "Oh, hey, we were in space." With a picture of astronauts.
Users, you can still view.
Okay. Oh yeah, it's logging me in.
Try to like /Peter Sounds or whatever the address is, because I can definitely view.
Are your tweets public?
Yeah.
Okay.
So you can view them without.
Yeah, there.
Yeah, you're.
Wait,
they just really want you to sign up.
They really do, but it makes sense, right? So anyway, huh? Yeah. That's all you need to know about me. Yeah. Anyway, so what?
1,769 followers.
Right.
You are very popular.
Let's make that 10.
That is, I think, 1,769 more than me. Yes.
But look, I joined in December 2006. That's like before you were born, isn't it?
Not before I was born.
Anyway, so okay, so the people talk about the timeline. Obviously, the timeline is the same word is used for. This is a timeline here, even though I'm not logged in. And when I do a search, I don't know, Ruby, Rails. That's timeline. Okay?
This is not a feed?
This is all the people that have...
This is the result of a search.
Oh.
This is a search result.
Right.
This is
then when is it a feed?
I think this is okay. The lingo is a little bit. Maybe I misused it a little bit. For me, when I used the word feed, I meant a timeline. So this is an instance of a feed or a timeline, but it was generated not by a person or by a list, but by a query.
Right.
Okay. Okay. Good. All right. The problem with sitting there in front is I can hear your music and I hear you telling jokes. Okay. All right. Good. So let's go a little bit further here and see. Okay, we talked about that. Great. So let's talk about nano Twitter. So I'm going to go this very granular in a way. Okay. By the way, the thing I forgot was, did you guys form up teams? Okay. Could you, during class, set up a Google Doc and share it with everybody?
Okay.
And have everybody type your teams and the members of your teams. And if you're not on a team, put your name by yourself, and we'll put you on a team. We'll find a really good one for you. Because I know the good teams. Okay, so what? What? Okay, so but what we're going to do in these teams of 3 or 4 students is we're going to build with Sinatra, with Active Record. We're going to build Twitter, baby Twitter, nano Twitter. But it's going to have a lot of functionality, okay? This is going to be serious business. And I want you guys to, and I'm going to help you take your way step by step. And by the way, Nick has already built this, so we know it can be done. He's also has the code, but it's in a private GitHub. And that's where it's going to stay. But here's what it does. Here's what it's going to be. So now we know what Twitter does. and we know something about the promised land, the way Rafi did it, and we're going to go a couple of steps in that direction. Okay? So here we go. So Nano Twitter, official spelling, little n, big T, just so you know. Baby version of Twitter designed as a platform for experimentation with scaling issues. All right? So here we go. So the first thing, we have users. These are like stories. I talked about user stories. These are stories. Users can register for an account by supplying an email, a name, and a password. Notice I'm not asking for you to create a complicated login dialog. Don't worry about encrypting the password. This is just an experimental platform. Users are never deleted. Logged in users can follow and unfollow other registered users. Okay? So if I tell you my name on this platform is petershouse@brandeis.edu, you can follow me by knowing that fact. Logged in users can tweet. Logged in users can see the flow of the last n tweets by the users that they have followed. So, in other words, I can see on my home page the last n tweets of all the users that I followed. Okay? So far so good? Pretty straightforward. Tweets could consist of 140 characters of text and a date time of creation. No worry about attachments, images, all that stuff. By the way, this is the minimum. I definitely would be very happy if anybody decides to get creative. If you love UI, you may want to make it a beautiful UI. If you love photography, you might decide to put images in. Go for it. But this is the baseline. Okay? Tweets always belong to a single user, and tweets can never be deleted. These are all simplifying assumptions so you know the parameters of what you're implementing. I'll come back to the REST API part. Next, the user interface. Very basic, what I call bootstrappy HTML interface. Bootstrap is a CSS library. Those of you who have done any HTML coding have heard of it. Those of you who have not, we will help you set it up. But it basically makes a website look respectable for relatively little effort. That's what, in fact, I'm using for this website. I'm using Bootstrap. So it's just very quick, get it looking relatively professional. At the slash URL, you get the non-logged in root page. There is a login link, /login. There is a register account link, /user/register. And there's a list of the most recent n tweets. And each tweet has a link to that user's page, that tweeter's page, user's page. The logged in user page is also at /. So if you're at /, it's going to show you something a little different if you're logged in or not, which is conventional. Okay? There's a log out link, /logout. There's a box to submit a tweet, /tweet. And there's a list of the most recent n tweets, which I sent. No, those are still the same one. But these are now for me versus the universe. These are the list of the most n tweets of the users I'm following. This is everybody. Specific users page is /user/name, where the name is the email address, or /user/a number, which is their ID in the database, basically. List of that user's tweets, button to follow that user, available only if I'm logged in, if the person's logged in. And if this is my own page, then it's equivalent to /. So in other words, /user/pedo, if pedo's logged in, displays precisely the same thing as just /, which makes sense, right? None of this should be surprising. Finally, user's own profile page, /user/profile, of course only when you're logged in, your name, your email, and a list of the users you follow. Okay, and remember again, you're welcome to elaborate this. Now, REST APIs. Yes?
Just quickly, so when you're on your own page, do you see the tweets of the people you follow, or do you see your own tweets?
You see the tweets of, I think I said the people you follow, but am I wrong about that? Maybe that's incorrect. The way it's written is a list of the most recent n tweets with a link. Yeah, this is the people you follow. But maybe it should be your own tweets.
No, because that's what the homepage is in real Twitter. It's all your followers' tweets.
Well, is there a profile page?
Yeah, maybe it's on the profile page.
Yeah, profile is your
Is where would be your list of your own tweets. Okay, I'll fix that. You remind me if I do that. Okay, so we talked last time in detail about the whole idea, and we talked about it today. Your homework on Monday is going to be along the same lines about Monday, about this idea of a service. Now, don't be tricked by the word REST. I'll get to what that is. It's just a certain kind of syntax for URLs. Okay, so the first thing, and I've given you the syntax, right? And I've given it to you right here. So the idea is that so all paths start with API/v1. If it's API/v1/tweet/23, it returns tweet with that ID as an API, not a page, but JSON. Okay? If it's /user/23, returns user information for user 23 as JSON. If it's /tweet/recent, returns the most recent end tweets, etc. So these APIs, these URLs, these gets, which begin with /API/v1, are going to return JSON, whereas the other ones are returning HTML. Okay? Sound cool? You think you can do it? I think you can do it. Piece of cake. If you do it right, it's just half a page of code. No, I'm lying. I'm lying. Questions about this? Yes?
What is due Monday?
Oh, no, not something different.
Oh, okay.
Sorry, there's going to be a homework that's going to be on the site tonight that's going to give you a little experience using an API. It's not this. It's to really make sure that you internalize the idea of an API by being a client. Because in a way, the API on the NT server, the NanoTwitter server, is there to help somebody who wants to write, for example, an iPhone app to talk to this. How do I talk to it? Use the API. Yes?
So when are all future homework assignments like related to this Twitter stuff group assignments, or like for like this API assignment?
No, that's individual. Okay. That's individual. It'll be clearly designated.
Okay,
Yeah,
that's what I was
yeah, it'll be clearly designated. Yeah, and we'll see. I mean, it's going to be interesting. I have like a whole bunch of extensions in my back pocket, but since it's the very first time we're doing this, I'm going to see how it goes and decide how far we go. Ideally, we'll go pretty far. So the idea is everybody builds their NanoTwitter server. It works like a champ. We'll have a day where we all log into each other's NanoTwitter servers and see if they all work. Some will do some cool things. Some will crash, whatever. But then they'll work, and then we'll start putting load on them. We're going to learn how to send fake load on these things to see how they perform. And then we're going to decide whether or not they're performing okay, or whether or not we need to fix things. And why, when I have only 100 users tweeting, suddenly the thing is dying, crashing the server? What's wrong? So we're going to analyze that, and we're going to see how to improve it. Again, with Rafi's thing, kind of like the extreme endpoint, which we're never going to get to, but we're going to start saying, okay, where can we put caching? Maybe we're not using the right database. Maybe the database schema is wrong. Maybe we should put some indexes in the tables. Any number of things which are going to now help your personal NanoTwitter scale better. Questions? More questions? Okay. Let's talk about the NanoTwitter design and architecture. Okay, so you can treat the first document I showed you as the spec. So in a way, when you get together with your team, you're going to look at it together and decide what's the thing we need to do first. And you're going to do that. And you're going to write a test for it. We're going to talk about test-driven design, and we're going to talk about writing unit tests, and you're going to use what we learned about Active Record to build a database and design a schema for it. So the first thing you do is figure out what the schema should look like. Given that the functionality of your product should do this, what should the schema do? What's one-to-one? What's many-to-one? What's many-to-many? What are the data types? You've got to figure all that stuff out. You've got to build the models, you've got to test them. It's clearly a Sinatra application, and it's going to mimic a lot, in a way, some of the homework you've done already in terms of the overall flavor of it. Initially, it's going to be Ruby code running on your computer. So you're going to have your NanoTwitter server running here. You have a browser on the same computer, and you're going to access it and see if it works. If it works, then, okay, you need more users. So then we're going to learn how to take your NanoTwitter server and put it into the cloud. There's a service called Heroku that we're going to use for that. and Heroku is one of many, but one of the early and really good ones. You get a lot of access to it for free. You probably can do everything you need to do without ever paying them any money. And Heroku, in a way, is a system that allows you to create multiple individual nodes, a database node, a web server node, another web server node, a caching node, whatever, and connect them up together in the cloud and operate them from your computer. From your own shell command, you can give it command and make it operate. What you get is a URL. You're going to get Peter's NT app.herokuapp.com, and now the 4 or 3 of you can now all access it at the same time and try to use it together and see what happens. And now you can start, since your code is all in GitHub, you can now start working on different parts at the same time. So very quickly after you have the very first part of your product working, we're going to deploy it to Heroku. Okay? The next thing that's going to be interesting is going to be the APIs. So one of the questions I asked in one of the homeworks recently, and I haven't had a chance to look at the responses, but I'm going to talk about it right now and see what you guys think, is who can talk, remember the famous homework from Monday? We had 2 workshops this week, and not many people went, which I was a little disappointed about. And I asked, what is the purpose of that client library? What was the purpose of that client? Okay? And I'd like to have a discussion about that. I think, again, I'll have you guys talk to people near each other and compare notes about why you thought it was. So take a couple of minutes, compare notes, and see whether you all agree on what the purpose was of it.
It basically separates a lot of things. I just forget what I
Whose homework may I look at? I want the permission of putting one of your source codes on the screen that successfully ran the unit test on the homework on Monday. Who? Yes. You probably did something crazy.
What? Sorry. Yeah.
No, I don't remember. Oh, this is you. Is it? Are you Amaris? Oh, Shimon. Who's Amaris?
Amaris?
What? Yes, Amaris. I thought. Okay, sorry. Huh? Nothing.
Oh, yes.
Don't worry, Shimon.
Oh, the client also deals with the errors.
Wait, I don't see your name.
You don't see my name?
You're trying to directly access this, then like huge errors. But the errors that are
Start from the press home.
like write it in the client, then you can easily say like, okay, if this kind of thing messes up, then write this.
You're not there?
So you can also split up the tests. Like, okay, if this is messed up, then I have to fix that part.
No, it's not there.
Uh-oh, better share it with me in the Dropbox, please. Who else that's on the list would allow us to look at your code, especially if the test ran? Okay. Anybody else? Come on. Yes? Help me find you. Do. My eye's not working. Yeah.
Oh, Clara Knight.
Yeah, but help me find it. Don't tell me I don't have you either.
No, something is wrong.
This is Cosi 105, right? Yes.
I don't know. Nick looked at my stuff.
Yeah, I have that.
Yeah, no, it's possible that one has it and the other one. Okay, somebody who sees it. Wait, let me make sure.
You're highlighting mine. You can do that. The unit test, right?
Yeah. Did it work?
The unit test did. Yeah.
So the whole thing worked. Yeah.
Should work.
Hey, I think
I think your Dropbox.
I think my Dropbox is broken. It's way broken. Look at this. This is not right. Oh, I killed it. Remember? The last class. I didn't kill it in this one. Oh yeah. No worry.
It's gonna take a while.
It's gonna. But I mean, it didn't.
It's gonna have to sync a lot of SQL-like.
Okay. Let's see.
Just take someone out of the chat.
Use the online client for Dropbox and download just the one you need.
No. Alex, can I use yours?
If you want, I wouldn't.
Did the test run?
Yeah.
The test ran?
Yes.
Okay, good. We'll use yours. So.
We'll see when it works on your system. Right?
No, I'm not going to try to run it. Oh no. What do these look like? Ah! What? Not my dad. Dropbox. Stupid. Is it? Yeah.
Is that you, Trigger?
No. So you Alex?
Ah, come on. No? Yeah, here we go. Okay, so what I wanted to ask is we're talking about user service, right? So you had a lot of time to talk about it. So here's service.rb and here's client.rb, right? Why, let me make it bigger. Whoa. Okay, why do we have these two files? That's my question. Okay. Why? Yes.
I think part of the things that we were talking about were, one, it's kind of a meaningful way to test the server.
Yes.
And two, it controls what you're doing on the server. It
Yep.
allows certain things and doesn't allow for others.
Yep. That's basically it, but let's go a little further. Who wants to add to that? Why is that needed? Yes?
The client also dealt with like errors. So,
Yep.
I think the purpose was to just like separate different methods. So if you have like one method, you can indicate this is the type of error, or this is the HTTP code you should be expecting, and things like that.
Yep. Anybody want to add to that? Because I mean, you're both correct. The notion is that, and this is why some people have trouble testing it because they didn't quite click on this. The notion is that the service, the service.rb and all its bits are running on a computer over there, and it's listening on the web for HTTP requests. Over here, I'm writing an application that wants to use that service. I have two choices. Well, I have 100 choices. I can know exactly what the gets and the puts are, what the syntax are, very low-level internal details of what the error codes mean, which is a real pain. Or I can, this person who built the server can make my life easy by giving me a nice bit of Ruby code that makes it all look very object-oriented, but inside it's doing all the icky stuff. Okay? So, if we look at this, the client of this, the person using this, doesn't know anything about JSON.parse and body, actually all this crap. Okay, and if we look at the tests, we see that I'm able to pretend as if there's this magical user class that actually can treat information that's actually on that Major League Baseball server in Boston as if it was right here. I can just do a user find by name and it looks very nice, and I get a hash back and it's all very clean. I need to know nothing about the ugly details of HTTP and JSON and all that stuff. And that is a fundamental pattern. And that's exactly when you use the Twitter API, or when you use the Wikipedia API, or if you use any of these APIs, the first thing you do is search for a gem as follows. Let's say I want to write a program that uses the Wikipedia API. Oops, sorry, I changed your file. Hide this thing. So I go over here and I say Wikipedia Ruby gem. I get a bunch of Ruby, and if I look down here, I will see sample code. And I can actually do this. Let's do this. So I'm using a client library here, obviously, because Wikipedia, I don't even know where that server is. I don't know what its URL is. I don't know whether it does gets or posts or what it does. I don't care. So let me get my I got to do gem install first. I got to get the gem, which is called Wikipedia. So I'm going to do gem install. Oh, not there. Sorry. So gem install Wikipedia. Okay, go into my fry, require a gem, whoops. Oh, dependent, interesting, this is dependent gems. This is kind of a flaw in this gem that it didn't tell me I needed this, so let me just see if I can, maybe this will work, maybe it won't. By the way, this happens also. I was going to ask a question, who wrote this gem? The gem might have been written by the Wikipedia Foundation, or it might have been written by, you know, Joe, the 12-year-old Brazilian coder, and uploaded it. I'm serious. I mean, you don't know who wrote it. It may be, you know, bad code, it may be good code. So when you're going to use something for an actual product, you want to go look a little bit at the provenance of the gem. But okay, we might still be okay. Let's see. Require.
If you were using this for an actual product.
Yeah. Keep talking.
I was going to say in terms of like copyright or whatnot.
Yeah.
Would you just have to accredit it to them?
Yeah. I mean, the fact that they put it on a public gem server means almost inherently that it's there for you to use. You would credit them in like whenever you're taking credit for the code. You'd say you wouldn't obviously patent it. You wouldn't submit it as your code, but no, it's fine because the fact that it's on that server means that they mean for you to use it. In fact, in the other class, we have a situation where a team wants to build an application that does something with stocks, and they want to use the Bloomberg stock service, and they're having that exact problem, which is like there's no client library in Ruby, so all they have is the low-level, you know, gets and puts in HTTP. It's not at all clear whether they're legally allowed to use that server because one of the members of the team happens to work at a part-time job at a company, and as part of that job, he's got access to that service. You know, so you gotta know what you're doing. Okay, let's try it again.
You don't think it's going to show up in the logs? Some brainless IP address.
Okay, so now here we go. Now I'm going to write regular Ruby. Wikipedia .find, of course, Brandeis University. Okay. All right. So this is obviously a half-baked gem.
Can you do like Wikipedia help? See what you got from there.
Well, this is a module.
Single quotes.
Pardon me?
Single quotes.
I doubt it.
What if it's just called Brandeis?
No,
there's no find valid.
No, but it's searching for.
Wait, why is it? I was just messing around with it. It was working.
It was?
I wasn't doing it in an interactive terminal.
You just ran it?
I threw it into like an app.
Oh, I didn't do Wikipedia client. Interesting. I installed the wrong. I installed the wrong gem, which again is very real world. Okay, so
question is, what did you install?
Right. Virus. Again.
But it's tricky because they just say require Wikipedia instead of.
Yeah, it's a little bit of a, I would say, non-intention revealing coding. If the thing is called Wikipedia client, it should be called Wikipedia client. Require. Okay, let's try it again. Okay.
All right.
Woo. Okay, so actually, by the way, when you see this for your non-Unix guys, it means that it's paginating, so if you hit space, you see the next page. Okay? So let me ask you, what possible advantage is it to see this in this gibberish versus in a nice web browser? What possible point is there to that? Why is this any better? Was that a hand?
No.
Okay. You know the trick. If you have your hand up, then you know the answer. Somebody was thinking about it. Yes.
You can parse it that way.
Huh? What's that?
So this is coming back in a JSON format.
Yeah.
So you can convert that to a. So if it didn't, you could do some other tricks on it. But because it's in JSON, you could only convert it to a key value pair, so a hash. And then once it's in a hash, you can do all sorts of programmable, and you could manipulate the data in a way that you wouldn't be able to if it was already in a user interface. And you don't even have to crawl it that way. So like the way you used to have to do it is just like crawl, get the HTML, and parse it that way. But this way, it's already in it.
Okay, but who can give us a shorter answer? Yes.
So this is essentially what Eden said,
yeah.
But it's much. This has titles, and you understand what each part is. So, one of the attributes I think is actually just title, like the title of this page.
Yep.
So it might be that you search for Brandeis, but the official title on Wikipedia is Brandeis University or something like that. And so it lets you do it in a very consistent way in your web app.
Yeah, it's interesting actually because, I mean, so to combine those two answers, the key is, who's the consumer of this information? Is it a person reading a page? Then you use HTML. If it's a piece of software that wants to do some processing, then you use this. Because here, this is not a very good response because I think these are all the different disambiguation cases here.
Like a search.
Yeah, so but if we dug deeper, we'd find more of them. So let me just get out of this and say Brandeis University. And
this looks more like a query than the other one.
Oh, it doesn't like. Oh, interesting. In prop. What's wrong with my? Funny that it didn't like that, but it liked that. Anyway, I won't spend more time on this, but here's the important thing to realize. The Wikipedia server is somewhere in Cambridge. I'm here. I'm using this client library, this gem, to hide from me all the gnarly details about access. And that is the purpose of this. Now, yes?
I just want to point out, you still got the improv, but now you also get the results.
Oh, yeah.
This you mean?
Look
at
up,
the top,
up, like the fifth
main.
from the bottom. Over the fifth bottom down from the top.
What do I have also?
It says the main unrecognized parameter improv.
Oh, interesting, okay. I mean, we could just look at it just for amusement to see what else. Page.title, page.content, page.categories. Okay, let's try that. Page is that, we got that. Page.categories. Okay, that's interesting. Page.links, page.images, page.urls. Let's put something more specific because they have an example with getting things done, I think, as a book title. And now we say page.categories.
So it looks like there's an optional secondary thing you can give to find. Yeah, that prop. They give the example prop info.
Yeah.
So it might be the case that if you go down, that's how we're getting sort of a warning. Is that we're not giving that optional secondary.
Interesting.
Something
Okay.
like that, maybe.
Yeah, could very well be. Absolutely. Okay. So anyway, but the main thing is I wanted to really nail in your head the idea of why this is fine. So why did you have to write a test for the client library? Why did you have to write a test for the client library? What were you trying to test, and why was it necessary? Because you have the test already for service.rb. Why did you have to write that test? Somebody hasn't spoken. Come on. Even if it's a guess. Even if it's a guess. Why did you have to write that test on the client library? You know?
No.
He's just visiting.
I'm in
just
deep
teasing
thought
him,
right
yes.
now.
Go ahead.
Well, client library might have
Client library can have bugs. And so you can have a service working perfectly, but in the beautiful code, it's hard to keep you guys awake this late at night, I tell you. Okay. In this marvelous code here, there's lots of code here. Could be lots of bugs, right? Let me ask you this. When you ran this test, and this is true for everybody, where was, like for example, when this test ran, and it said, this is the client itself, sorry. When this test ran, looking for name Paul, and so on and so forth, what was it testing, and what was it doing, and what was the success criteria? What was it testing? It said, get API users Paul. Sorry, that's what I meant here. And it said, oh, I'm testing the client library. No, I'm not. No wonder, okay. Try it again. I was doing here, user find by name Paul. And remember, it would do this first every time. So it would do user base URI blah, blah, blah. User destroy Gosling, user destroy Strother, whatever. And then it would say find by name Paul. What was that command doing? This is on the client. It's the client library. It's the equivalent to the Wikipedia thing I had. And it was what was it doing? What does that one call do? Anybody? What does that one call do? That one line number, what is it? What am I looking at here? 12, yes. What was that line doing? Give it in as many words as you can. Yes.
Wait, in as many words as you can? Because then we should give it to Eden.
Oh, you're so mean. Poor Eden.
Poor Eden.
Yeah.
Everyone abuses poor Eden. So the line 12, its way of testing is that in client.rb, it sort of, I guess not overrides, but adds methods to the user object. And those that it adds, like find by name and these other ones, go and try to do it through the API using type.
Typhoeus, I don't know how to pronounce it either.
Yeah, I don't know. There's too many vowels at the end.
Yeah, I agree.
But it tries to actually access the API server.
Right. Yes, go on. And then what is it telling the API server? So it's going over the wire, talking to a server that's in Boston. Yeah. What's it telling the server to do?
So it depends on each thing.
Well, find by name. Here it is, right?
So, it'll say, okay, I want to find this user's name.
Yep.
Or
the user with this name.
Rather, I want to find the user with this name. And then it just says, hey, if I get a good response code, return that.
Yep.
If I don't, then return nil, which will throw random other errors in your testing.
Client. Yep.
That's fine.
Yep.
And then if you get some super weird error that's neither what you expected, then you just return.
So this user class here, is it different or the same as the one you had in that model file?
Different.
Why?
Because I just created it in this one.
Okay.
So it's more local.
Why? Anybody want to talk about that? So there's a user model here, class user, and there's another user model here. Class user. What the hell? Anybody? First of all, why is there no conflict? Why does it say, hey, user already defined? Yes?
Because you're never loading them both at the same time.
Right. One is in the client, gem Wikipedia, the other one is in the server when I'm running the, and they are both totally different classes. They just happen to have the same name. Why? Because the one that's running on the server, that is this one is talking to the database. This one is a classic model class that is a stand-in for the database, and it's bringing back records out of the database. That's what it's doing. This one, its counterpart on the client, is trying to create that illusion that it's standing for the database, but it really isn't. It's actually standing for a request across the wire to the database on the other side. But you call it user because you want to create the feel for the programmer who's using the client library that the user is right here. Okay? So the client library does a lot of things. The big thing, just like when I just used the Wikipedia client library, it wants to create the illusion that Wikipedia is right next to me and I'm just using it. But actually, it's way over there. There's all this communication going on. Same thing here. It's trying to create the illusion that the user database is on the client. And so when I say find my name, it's not going to ask the database. It's going to send messages to the other side, requesting it. And if the response code comes valid, then it's going to go, I found the user. And that's what the client spec is testing. It's testing whether or not the illusion that the database is right here is properly created. And the fundamental purpose of the client library is to insulate the programmer who's using that library, just like I just used the Wikipedia gem, from the gnarly details of communication across the wire. It has also other advantages, but basically that's the essence of it. Okay? And we're going to do the same thing when we write tests for our Twitter, Nano Twitter. We're going to make a client library to prove, A, that our API is working correctly, because it's one thing to test the API from the server, but if you want to test it across the wire, you need a client library. So we're going to build a client library here too. So,
sorry, this naming thing?
pardon?
Is this naming them the same thing? Is this some kind of defense mechanism against loading them at the same time, or is that just silly?
No, it's not. No, it's not that. Because the user of the client library doesn't know anything, theoretically or conceptually about the server. It's more to I think to create the illusion. It's like in the Wikipedia one, because sometimes you don't want to show anything about your actual data model. You want to create a totally different one that's much more close to what the user wants. So that's what it's for. So we have the service. Let's see, the Nano Twitter service. We have web browsers that talk to it with HTTP. And we have, how do you draw this? A plug. It's more like a jacket, a socket, called the API. And on this side, we have some, let's say a mobile to make it more intense. And it's talking over the network to the Nano Twitter service. But we don't want him to know anything about this protocol. So we write a little bit of code here, which is called the Nano Twitter client library that can be called on iOS, and it talks to this. The author of the Twitter service wrote this code, your team, and the author of the Twitter service wrote this code, your team. You give this code to your clients, to your app developers, and you say, hey, you want to access my Twitter service? Just use this library. That's all they need to know. They don't need to know anything about how that works. That's the purpose of the client library. That's why when you try to run the test, some of you did, the client library test, and it didn't work, and you got these strange zeros back from Typhoeus, because you didn't run the service. So it was as if you wanted to try to test this thing, but it was trying to talk to a service that was nothing there. That's why you have to start the service first. Okay? All right. Running out of time, but I think I'm okay. Okay, so we talked about language and framework, boom, testing, automated unit tests for the client and the service, and then there will be need to incorporate instrumentation, that is ways to measure performance, and we'll learn about that, to monitor its performance and detect bottlenecks and other problems. The base case will be to use a service called New Relic, which you'll learn about as well. And finally, the project outline. I would call this an approximate recipe. This gives you a bit of a roadmap, and I'll tweak it as we go. Then I want to just talk through it. So, first thing to do is, in fact, I'm already going to change, no, maybe not. Design the HTML forms that you need. And I listed them, you have to just write the HTML for them. Design the integrated relational database schema for the whole app, based on your knowledge of what all the relationships are. Implement a Sinatra front end for the UI. Use Active Record and Postgres, like we've discussed. Implement a large body of seed data with automation. What is seed data? Seed data is a term, I think we might have used it already, which is just, if you want, when you first launch your server, for it not to be empty, you write a lot of fake data, fake users, fake tweets, fake posts, so that you're not always looking at blank pieces of paper. You have already 1,000 tweets, you have already 1,000 users, and I'll show you how to generate fake data. Write complete set of tests with automation. We're going to be using Minitest spec. Revise the user interface to make it pretty using Bootstrap. That's already pretty. Deploy to Heroku, make sure all the tests still run. And I'll improve this to add client versus server tests. Now you're probably going to iterate through this. I'm going to recommend that you go through for a subset of the features as far as you can, and then go back and add more features. Implement them as further go back to the beginning and design external API URLs. Implement them as further Sinatra routes. Write a complete set of tests for them. Investigate and choose a way to load test your app. We're going to give you a better one than this. So load test this, subtly make it look like there's 700 users arriving within a 1 minute span. What does your server do? Investigate and choose a way to instrument your app. See, for example, New Relic. That's going to tell you, oh my God, after the user 350 came, your server died. Then do a series of load tests and write a report of your findings. Let us figure out how bad it is. Different people will have different results. Some of you may be clever and go ahead and start making it better already. Update your schema to put indices and other enhancements to see the effect of scaling. Try different databases, SQLite, MySQL, Postgres, Mongo, see the effect of that. Do scaling experiments and see the differences. Investigate and figure out how to set up a Redis caching service, okay, to start caching, and you're going to do a subset, obviously, of what Rafi talked about. And then consider and figure out where to add caching throughout to get the scaling up and up and up and up. Okay? That's the plan. And this is what your team of 3 or 4 are going to work on in the next N weeks. And we're going to be giving you guideposts, not do step 1 now, but more like you should be around step 1, 2, 3, 4 right now. And you guys will play within that. And really, I'm not going to insist that you follow this scheme, but people find it useful to have at least a bit of a trail. Okay? I think that's basically it. Any questions? Okay, pretty clear? So there's now already a Google Doc for everybody to put their names on. Either put your name together if you're on a team, 3 or 4 people. Invite somebody onto your team if you have all the superstars to get some people that are learning. If you don't have a team yet, or you don't like your team, put your name at the bottom by yourself and we'll help you find a team. In the end, everybody should be on a team of 3 or 4 people. Okay? Before you go, so on Monday we're going to talk about databases. We're going to go a level deeper into how to create a database. We're going to talk about relations and all this sort of stuff. Okay? This is coming. By tonight you'll have this. Hang on, guys. One. The first bullet is going to be hard. It's just not, there's no detail here yet. Okay? Write a program that uses a client API. That's going to be up by tonight. Okay, good. Thanks.